Good morning. Welcome everyone to this webinar called the Unlocking the Secrets of Proficiency Testing Assessment. So my name is Peris. I'm the General Manager of GSC, and I introduce you to Marneus Bañuls, please.
Good morning, everybody. I am the person in charge of the export sales in Europe, and we're here
to have fun today. To have fun today. This webinar is going to be performed in English, so don't worry. It will be easy because we are very in charge. That we are no of us are native English speakers. Anyway, the whole presentation will be sent to you afterwards, and so you will have all the information. The webinar will last about 45 minutes, 1 hour, depending on how many questions. Even we can go further to answer the questions you want to present to us, or further on we can answer it by email. So let's start this unlocking. Let me introduce GSC just for 1 minute. We are a company that we are working in the field of consulting since 30 years ago. From the very beginning, we wanted to give a comprehensive service to the conformity assessment bodies, which are the laboratories, of course, giving consulting, internal audits, training, and interlab proficiency testing for them. As I've told you, we wanted this 36 degrees portfolio to labs. We have 30 years of experience, even more. We are collaborating with accreditation bodies and certification bodies. Some of us are assessors in these bodies. And we have, in this moment, a very big, huge offer, also in proficiency testing. For example, we make tailor-made proficiency test in national reference laboratories as other services, and also international bodies as well. And of course, one of the most important things we have is that we are accredited under ISO 7043 and other recognitions as ISO for certification. So let me tell you, I'm sure that all of you already know what is an interlab comparison. Yes, it's an event, where a lot of laboratories measure or test the same sample or very close by sample, yes, for a purpose. In this case, the proficiency test is a kind of interlaboratory test. Proficiency test is where our name, PT GSC, comes, and a proficiency test has the goal of giving an assessment, a final assessment to every laboratory. From the very beginning, the interlaboratory proficiency tests and accreditation or certification has been very close. Sometimes in some schemes like accreditation, they are mandatory as quality control. But also in certification, there is a need to have an external contrast. So this is where the proficiency tests take a very important role. There are some of the main reference documents that are involving the proficiency test performance, but more important than the content of these ISOs, which is are very hard. What we know is that it's not always easy to understand a proficiency test report, your results. So this is the idea that came to us to give this webinar, to explain some of the key points that you must know to unlock what is written in the reports. What to consider when you are selecting a PT provider? There are a lot of things that you have here, a huge list, but one of the most important things is the statistics, where we're going to dive deep today. a little bit, and also the results, their reporting of the results, which is something very important you must know and you must understand to give to you also a good assessment. Basically, talking about statistics, there are 3 steps in proficiency testing you must know. The main goal is at least to get a laboratory assessment, CITA score, or any other statistic that the provider use. But for that, it's necessary to know how the most important, the 2 points that are used to make the assessment through the theta score, which is the assigned value or reference value, and the sigma for proficiency assessment or accepted dispersion can be calculated. This is something that we will go today. And finally, to have a good image and a good value figure, at least of the assigned value, it's important to know how to detect the outliers and what to do with them. No, so in the assigned value has not influence of the extremes or outliers results that the laboratories give. So mainly when you are participating in a proficiency test, what are you looking for? What do you need participating in a proficiency test? To get a good score, to find that your performance is good, no? So, and how we consider that our performance is good in the laboratory? What do you do? What do we measure? Classically, what we do is immediately take the report and take a look to our CETA score. It is good. It has been good. Normally, and actually, if it is yes, we say it's okay if our CETA score is below 2 in absolute figure. And it's not good if our CETA score is above 2. But this is not always the true. To have a CETA score under or below 2 is not always good or not good. All depends on how this CETA score has been calculated. So the CETA score calculation must be reliable. What means reliable? And each provider makes this calculation as they wish. And you must know how they've done it and agree with this way of doing these calculations. You see that the CETA score depends on the assigned value and depends on how wide or how big is the sigma that is used. So CETA score is not everything in the assessment. And then you will say, oh, and how can I know that if my CETA score is reliable or isn't reliable? Well, first of all, I want to introduce you. I'm sure that most of you already know which is the meaning of the CETA score, but I wanted to explain a little bit. A CETA score comes from the knowledge that the results of the laboratories follow a normal distribution, a Gaussian distribution. That means that there is a central value, the most likely value, which is called mu, or in our case, the assigned value, okay? The assigned value. And how wide is the distribution? The distribution is measured by a parameter called sigma. And what a normal distribution means is that if you are from the assigned value or reference value 2 times sigma, until this distance in this side and in this side, you belong to the population with a 95% of likelihood. So if our value, if our result is here is our result, that means that our z-score, the difference between the value of the laboratory and the assigned value in absolute figure is equal to 2 sigma. Yes? So what happened? That if we pass the sigma here, we got to the concept of z-score. So you can understand very well that the z-score has to come from a good assigned value, the most likely. So the outliers must be removed, and a correct, a fit for purpose sigma. We go deeper to this question. Here you can see what happened in for example, two proficiency tests, different proficiency tests with the same assigned value, the central one, as you see, the same assigned value, but this population, the green one, has a 2 sigma, for example, here, okay? Plus 2 sigma, okay? And the blue one, the 2 sigma comes here, more or less. So, for the same assigned value, if we are in a proficiency test round where the sigma is here or is here, depending on how is the population, if my result is 12, that means that my assessment according to the green population will be with a z-score above 2, but if I'm in this other population, my z-score will be good. So it's important that the z-score is as huge as it could, so we are sure that our result has more likelihood to be inside and to have a z-score below 2. No, the sigma must be fit for purpose, must be in coherence with the kind of test we are making. So, as I already have explained you, the assigned values, the assigned value is one of the, what means the center, no? The most likelihood value of the population is the reference, the true, and the most likely, as I've told you. But it's important to obtain this value very reliable. That means with a small uncertainty. And the second value, the precision, the sigma for proficiency assessment, indicates the maximum acceptable difference to the central value, to the reference value, that where we're going to assess as acceptable the results of the laboratories. So all the standards and some of the accreditation bodies, I'm sure that in your countries this is being demanded or is going to be demanded very close, must be appropriate and must be objective, must be a target. It's a sigma that you should know even before enrolling in a proficiency test, but must be published in the web page or in any other means that the proficiency testing provider gives to you to know his offer. For the assigned value, there are several approaches. Sometimes the reference value comes from external values, reference materials, or a reference laboratory that performs reference method to set the assigned value. Those are not very common at all. But by formulation, by addition, spiking samples is sometimes the way to know which is the reference value, the value that all laboratories should reach and should get. We use very often spiked samples, not only to give a reference value, but also to be sure that the amount, the level of contaminants, of microorganisms, of metals, of any contaminants that are rarely nowadays found in food samples or in water samples are present. Otherwise, the items that we give to you have not many interest if there is not something that you can count, that you can measure, that you can give a result. But most of the times, the result, the final result, the reference value comes from the consensus of the laboratories or of the whole set of laboratories of only from a group of experts laboratories. For example, this is something we use when performing a proficiency test all over the world with the International Council, Olive Oil Council, where only the official panels are the ones that can give the assigned value to the olive oil. But if we want to have as reference value, as assigned value, the mean of the consensus, this consensus should be really a consensus, shouldn't be very affected to the results that have come from a bad performance or have some mistakes in the expression or certainly are really wrong. In this case, it's very important to have a good test according to the standards that makes possible to detect which are the outliers. Because sometimes it's not easy to find which are the outliers. No? Some numbers, some figures are really clear that they are outliers. But in this case, we don't need really a test to recognize them. No? But sometimes it's not easy to see which are the ones that are not statistically the same as the others. And we use this kind of test to detect it. Once the outliers are detected, there are two different approaches about what to do with them. One of the approaches is that those outliers are corrected. So the proficiency testing provider just change the number that the laboratory has given to a different number. And this is what the A algorithm does. And this algorithm is quite used all over Europe. But it's a correction. But what we can do also is once are detected, we eliminate those that are wrong, that don't belong to the population. And for that, we can use two different also approaches, robust statistics, which is the one that the standard, the ISO 17043 hardly recommends. Or this means robust statistics means that the median is the figure that is used to detect the outliers. When the mean, when the average is the figure that is used to detect the outliers, then we are using a descriptive statistics. This is the kind of test like groups, Cochrane, and some others that Dixon, that probably you've read sometimes in some of your reports. But this kind of tests are not very effective. This is why the standard, the ISO 17043, recommends hardly to use, as far as possible, robust statistics. We used robust statistics based on the median of the laboratories, and we eliminate the outliers. But let's go a little bit deep to understand what is happening when this approach and this other approach. And I have a graphic, I have a plot. I know that the colors are not the best ones, are not the most beautiful, but it's the way that you can see very clearly what I want to tell you. So you can see in pink the real results that the laboratory gave, okay? So you can see that there are some results here that are like far away from the center, some others here, and here you can see them. If we use the algorithm A, the correction, this is exactly what it does. All those results are concentrated in these blue towers that you can see around the central point of the graph. So that means that if the towers are not very equilibrated or are big, the mean, the final mean, which is the consensus value, is going to be also affected. And affected finally by the results that nobody has given. It's just a number, a correction. In our case, what we do is to reject is the green approach, the green graph. All these results have been removed as outliers. And that means that the mean is not affected at all anymore by those extreme values, okay? So I hope that you now understand a little bit more about what your providers tell you in the reports. About the lower part of the CIT score, the sigma, the precision value, sigma, also can be obtained by different means. Of course, something very comfortable for the provider, very easy, is to get a standard deviation of the results of the participants. Just a standard deviation, doing nothing else. But that means that sometimes the standard deviation will be like very huge. Do you remember the blue curve? Or very sharp, very narrow. So it all depends on in which population you are involved in this proficiency round. But on the other hand, there are ways to set the sigma by external means. For example, by prescription based on legal data or precision. I don't know, regulations about heavy metals that says that the reproducibility of the laboratory should be lower than a certain value, or in the regulations about water, clean water also tells about which should be the uncertainty of the labs for each one of the parameters. So there are legal sources of that point us which sigma must be used or should be used, or all the laboratories should achieve. And also we can find this kind of information in the content of the methods, of already valid methods, like it happens in the ISO. Sometimes the methods have a chapter of precision, bias, and it tells you which is the reproducibility that should be used. So sometimes this is from where the sigma comes from. And also there are many other general models that are widely used all over the PT rounds, like the Thomson or Horvitz formula that makes a correlation between the level of the contaminant, of the characteristic we are investigating, the level, concentration, and the precision that we should achieve as well. So it's for sure that B, C, and D, as you can see here, are the only ones that provide really a sigma target, something that you know before you start the proficiency test round, and avoid the influence of erroneous values on the results that the laboratories are giving. Okay? So you have a slide here that resumes a little bit this. You will get it, so I don't go deep in it. It's just a summary, a resume of what I was telling you. We've been talking about CIT score, which is the most known parameter for assessment. But sometimes, because there are few laboratories, not many of them, at least 8 or more, but sometimes we have not 80 laboratories, we have 20, 30, 15, and sometimes what happens, new parameters, new methodology, etc. Sometimes the assigned value has an uncertainty which is not as good as we wish. It has an uncertainty above 0.3 times the target we're going to use for assessment. And in this case, only in this case, what means is that this uncertainty is not negligible according to the sigma target. So we should add it here to make the calculation. In this case, this parameter is not called zeta, it's called zeta prima score. And both of them, the meaning is exactly the same. If the zeta score is under 2, the result is satisfactory. If it's between 2 and 3, we know that we are here, which is not the best result in the world, but we are questionable. But if we are here, then our result is unsatisfactory. This is why it's very important to see, to know, and to agree with the value of sigma that is going to be used for calculations. There are some other ways to make the assessment. For example, there is one very known in metrology, but also we use it as something complementary to our assessment, which is the normalized error or compatibility index. In this case, what we do is that we ask for the value of the laboratory. Oh, sorry. We ask for the value of the laboratory and its uncertainty, okay? Sorry, UL. And we know the assigned value that can be here, assigned value, and its uncertainty, which is this one. Okay, this uncertainty expressed at a 95% of likelihood, like expanded way of expressing uncertainty. If this normalized error or compatibility index is above, is under 1, that means that there is an overlap. You see, there is an overlap of the result of your lab and the assigned value taken into account according to the uncertainties. In this case, when it's between 1 and 1.5, there is not an overlap with this uncertainty, but with the uncertainty calculated at a 99%. And in this other case, what we have is that your value and your uncertainty and the assigned value and its uncertainty both don't overlap. So the compatibility index or normalized error says that there are not compatibility. This is something that we do. We report it in a different report, but there is a thinking about how well your uncertainty has been measured, has been estimated, has been calculated. So it's something additional besides the set score that we always calculate for you, but also the compatibility index is something very common in our proficiency test. This is what happened when your result is a number. It's something quantitative, but when your result is qualitative, the results are just expressed as presence, absence, positive, negative, yes, no. And so the classification from set score is impossible. We cannot do it. We cannot calculate the set score as a normalized statistic that I've told you before. But rather, what we say and we assess is like, it's okay, it's correct, or it's an incorrect value, according to the knowledge we have of the nature of the sample and all the checking that we've done with the sample, with the control laboratory that has to check, of course, homogeneity, stability over the round. So the reference value is always according to the preparation after checking that all the specimens that have been checked agree with presence or absence of the property we are measuring. In microbiology, there are special aspects that must be that we must consider, starting from the fact that the living beings don't follow a normal distribution. There are discrete distribution that follow more a Poisson or binomial, negative binomial distributions. So that means that directly using the same statistics is impossible. The samples include living beings, so stability and homogeneity is very important, especially when in our case, we send natural samples. So you don't have to do nothing with them, but test them. Also in micro, the methods sometimes brings you to a final step of confirmatory methods, which are different from one lab to another lab, the number of colonies that are confirmed, the test that we are using. So that means that may give different results from one lab to another lab, and the precision between labs can be bigger. So to solve these problems, we use all the proficiency test providers actually use statistics with a previous step. That means to transform all the results into logarithms, which do follow a Gaussian distribution, because it's impossible to know the real value as real. What we use is the average of the laboratories after removing outliers, of course. That means that in microbiology, actually, we need a significant number of participants to have a better approach of the average. Sometimes also the methods, as they are different, we need to make different statistics according to the methods that have been used by the participants. Always accepted sigmas, target sigmas are used for calculations, sometimes come from the status of the art, or sometimes comes from the reference methods. And as I've told you, if we find a bias between the results of one method and results of another methods, we use statistics, different statistics for each one of the methods. And in qualitative tests, the same rules I've told you before are used. I would like to tell you also about some other technical aspects that you have to consider just before letting Marneus to explain you and to point and to set all this information in a report, in a real report. And this is something very, very important is to know which is the nature of the testing test item. The standard, the ISO 17043 says that it should be as real as possible. And expressly says that the provider should avoid standards, pure solutions, etc., because they don't represent what the laboratory really is it's analyzing and is manipulating, is handling. So, well, of course, we must grant homogeneity, etc., etc. It's important for you as well that when you take a report, take a look to check how your CIT score has been calculated. We know what is a CIT score by now. You already knew it from before, but now we can go deep and to search in the report how the assigned value and his uncertainty has been set, has been assigned. If it's consensus, we must take a look to the final number of participants that has been the assignees of the value, and there has been a procedure for detection of outliers. And what has happened with those outliers at least? Have they been removed? Have they been corrected? Which sigma has been used for proficiency assessment and where it comes from? Because you can agree with this sigma or you don't agree with that sigma. Remember that the target or any sigma that is used in the proficiency assessment, any target sigma should be evaluated by you as fit for your purpose, for your field of working. And finally, there is a content of the report that at least must be clear and complete. This is something that when I was working in laboratory, something that I disagree very much sometimes because I didn't see the results, the numbers, the explanation, nor clear nor complete. And while there is a lot of information, you have a list here and also some details of what you have to look after in the report. And Marneus is going to explain you now with a real example where to look for and find this information, which are the most important key points in a report to help you to understand better your performance. So I say you a short goodbye, and I will say goodbye later. And I thank you very much for your patience. I know that this is not the most funny topic to talk about, but we are very happy that we had more than 300 inscriptions. And I don't know how many people are now connected, but I hope you have enjoyed. And please, Marneus, as when you want, you can start with your presentation.
Hello again. I'm going to disappear from your view. I'm going to explain the report, but you actually won't see me, so you're just going to hear me, and that's going to help for you to have a look at the proper report without me in the middle. Okay, so I'm going to disappear for a second.
Yeah, while Marneus is looking for the report, she wants to explain, to show you. I just want to remind you that you can write down in the chat all the questions you want to be answered. We want to treat, and as far as we can, we're going to answer afterwards or after the webinar anyway. So write down because I'm going to, my colleague is going to collect them, and we're going to take all and answer certainly. Thank you. I think that you can already see the report in your screen, because we are sharing this report, example of the report. So, okay, Marneus, thank you.
Okay, so this is an example of one of our microbiology report. It's quite long, so I'm going to scroll down a lot. So we're not going to repeat because we have a lot of participants in this report. The things get repeated, so I'm going to scroll a lot, but it's not because I'm missing information. It's just for you to see what you need to find in the report. So obviously we have a lot of literature in here, and then one thing that you need to stop to and to have a look at is what has been used for this. So these are the reference documents used for this proficiency test, and then the number of participants. So you know that it had been 85 people participating in this PT. So it's a lot of people, also from different sectors. Okay. So then you go through the parameters, and this is an important part of the report where you can see the nature of the sample. So you know this proficiency test has two samples. One with salami, which is this is a meat product, a meat PT. So you have salami, and then you have a pork burger. So two different sets of samples. Okay, and then it's a little explanation on how the samples go to the laboratory, if they're frozen or not, etc. Then you have a description of the sample composition. Okay, and so you get into this point where you can see that these samples were spiked by these strains. The number one with E. coli and Staph aureus, and the second one with Listeria. So what you have is the number of these, the counts of these spiked samples that you will use as a reference, and then you will have also the detected in 35 grams. Okay. Hang on a second, I don't know what happened here. Sorry about this. I don't know. Sorry, I beg your pardon. I apologize. We're having a little issue. No, sir. I guess it's not, you know, seeing this. Do you know what happened? Well, basically, we're going through the individual report now as well. Okay. We're back again. I'm very sorry. I'm very sorry about this. Okay. So I apologize. So you can, well, let's go back to where we were. We were in point number 4, I believe. Where I was telling you the nature of the sample and the matrix and the sample composition. And then I was telling you that these samples have been spiked with these different strains, and that is the total counts that we previously had prior to send the samples. So you have, obviously these samples have been done homogeneity and stability studies prior to send the sample. And then we get into just a more interesting thing. So here, what is important here to know that our objective sigma or our sigma target, in this case, it comes from an ISO 4832, where it states that for aerobic microorganisms, we need to use a sigma target of 0.25, and for enterobacteria, we need to use 0.35. So you know, prior to that, that these are the sigma target or the sigma objectives that we need to look in our tests, in our results, sorry. Okay. So then obviously it's a lot of information in this report. We get all the information about the schedule, the date it goes out, the results deadline, the statistical treatment that we are going to provide, which is the Gaussian distribution, as Anna mentioned before, the elimination of outliers, as Anna mentioned as well, how we're going to do that. And then all the series of formulas that we used in this particular one to get a response. I'm not going to go through one of that in depth, but because it's going to be very, very long. So it's just to show you that all the information that you need to know how your lab has been performed, it is in the report, and how we say that it's satisfactory or questionable or not, according to what just Anna told us. And then we get to the important part of the report, which is the final summary. Okay, so for instance, here we have what was the detection of Salmonella, so this qualitative with a theoretical value, and the results issued as detected or not detected, in this case with 95% detected, and for pride not detected. Okay, and this other parameter, when we're talking about Enterobacteria, coagulase positive Staphylococci and Escherichia coli, we use the target sigma that the standard told us, as we said in the previous explanation, 0.35 for Enterobacteria enumeration and 0.25 for aerobic counts. Then this is the assigned value that we given, that it comes from. Remember, it was 85 participants. Now only 69 in this case for Enterobacteria, 63 in case of coagulase Staphylococci, and 73 in case of E. coli were the ones that actually responsible for the assign this value. Why only this number if they were 85? Because some of them, the outliers have been removed. So this is the assigned value. So in this case, what we have is that is a consensus value given by the group of laboratories, by the group of results that we have. So this is the value in terms of colony counts. And this is the sigma target, as I mentioned to you. This is the standard uncertainty. That's got to be 95%, as you can see here. Okay, so that's the same for the other parameter of the sample number 2. And then on we go with all of this being exactly the same because it's 85 participants. Now, what happens here that we have to, this part is where the participants can comment anything and everything they want to say. In this case, they say the methods that they used, details on everything that they want to introduce. So obviously it's a long sheet because each laboratory has a lot to say, how they did it. And in some cases, you will find this kind of hidden or covered information, and that is because only for security of the laboratory, right? It's because it's confidential. So that when it's confidential issues, we just covered and no display. No display, because remember, this is always confidential. And so go on and on until, because everybody says what they done it, what method they used, everything, anything that they want to say. And then we come to the final assessment, where you can see the participants listed from 1 to 85, the ISO method that is being used, and the results, in this case, expressed in colony forming units. Okay, so each of the participants can see what the result was. And so on we go. Whether they use tempo, whether they use whatever, anything, and so on and on we go. And then we get to this part where we can see that what it was satisfactory and what was not. So we have here, this is the important thing to see, that the value was 4.05, which was the consensus value, that the 0.25 target was assigned by the organizer as technical consistent, that comes from the ISO, and the uncertainty on the standard uncertainty for the consensus value is 95%. So here we have all the laboratories that gave satisfactory and not satisfactory. All the T's are the ones, here is the Z score, which is what we said before, the setup previously. So you can see why your result can be satisfactory or not satisfactory. So we go until we reach, and scrolling down because obviously it's a lot of participation here. Okay. And then obviously everything is explained underneath every of the tables. And then we get to plot a graphic of all what is happening here. We plotted as an Instagram, I think it's called, this plot, and then the normal curve that happened with all the population that we received. And this is for the Staphylococcus assessment, and then start all the enterobacteria. And again, this is, we repeat again, while the ISO method was used, the proper counts that the sample gave in terms of CFUs, the methods again. So it's long because it's lots of participants, and I'm sorry to be scrolling because it's the only way that we can show you all of this. Okay, and then this is what happened. Again, look the same. This is before was with aerobic counts. This is enterobacteria. So the same here, the satisfactory and unsatisfactory.
Okay. Marneus, maybe you can show an individual report.
Yeah. Just very quickly, I'm gonna show you what is the individual report here. I don't know, it doesn't come on show. Okay. This is the individual report. I hope you are seeing it. And what you can see here is that this laboratory in particular had all these parameters.
This is a chemical one.
This is a chemical, sorry.
No, it's okay. You can show this one. It's the same thing.
Well, it's the same thing.
Another parameters. In this round, for example, what we are sending are 3 different bottles. In one of those, we ask for ammonium. In other, we ask for chlorine and free chlorine and total residual chlorine, and some other characteristics are demanded, are asked in the sample MC. And what we show.
So again, we show the results. In this case, the mean of the results, the evaluation of the CT score, the assigned value, and the sigma target. So this is individual report. So every time that you participate in the proficiency test, a laboratory participates, you receive 2 sets of reports, the general one and the individual one. But sometimes, in cases it's needed to have an uncertainty report, is a 3rd report issued. But that is not everybody receives this, it's upon request, basically. Well,
yeah.
Okay.
No, what we do, yeah, we can stop sharing now a screen. so they can see us again. So here,
Okay.
here I am again. I was collecting some of the questions that you wrote in question and answers. Well, just 2 points, and certainly there is a question that can help us to solve this issue. A laboratory asks if it's mandatory to declare the uncertainty. It's not mandatory. I mean, what we are doing is that we ask in chemical reports, in chemical parameters, we ask always for the uncertainty of the results, because we want to make this third report where we check how is your uncertainty by the normalized error or compatibility index I told you before. But even though if you don't introduce your uncertainty, nothing happens. I mean, you cannot introduce it. Sometimes you are not accredited yet, or you are not thinking about accreditation in this particular topic, and so you don't have a calculation. It doesn't matter. You can introduce your result, you can declare your uncertainty result if you want, and you will get this other report, or if you don't want, you don't need to do it. So there is another question, which is, do you have any statistic tools that allows you to recognize different populations when different methods are involved in one round? Yes. Certainly, also the ISO 17043 enforce to do that. We have tests for bimodal populations. So we make calculations with separated methods, and if there is a bias between the average that is recorded by a method and by another method, then we perform the separated statistics and we make the assessment by different statistics in these cases. So this is something that we always do. Sometimes it's very common to do it differently. Another question is, can laboratories be rejected for other reason but for statistics? Yes, of course. What we have to do in our proficiency test round is that sometimes we give certain instructions that must be followed about the amount of sample, about following a certain standard. Sometimes it's mandatory to follow a certain standard. Test standard, and all the laboratories that haven't followed this standard, their results may be good, but are removed for the calculation of the assigned value. Anyway, we always make assessment of all the results, rejected, of course, if not rejected, but also the ones that have been rejected because they didn't follow the instructions, because they didn't give the expression of results that was demanded, or because they have been removed by the test, or because they have expressed their result as a limit, no? Minor limit of quantification or a limit of detection. And still, this is something that sometimes laboratories ask by mail to us sometimes, and says that, can my result appear as removed by the test and my set score is satisfactory or questionable? Yes. When removing outliers, the test removes results that are clearly bad, but sometimes removes results that are close to the population, but not as they are not statistically compatible with the population. Statistically compatible doesn't mean that your result is wrong. In fact, when using a sigma target, it can happen that your result has been good enough. For example, maybe I can explain here for the person that has made this question. Sometimes, by pure luck, like by telephone calls, the population, the real population is like that. You see? So very sharp. I don't know. Nitrate, 50 milligrams per liter, and 2 sigma, the experimental sigma, brings you to a very narrow curve. So most of the results were 50 milligrams per liter, but some laboratories have report 51. This is like very exaggerated example, no? But some 51 or 49. If we use the sigma, experimental sigma, those results clearly will get a set score like unsatisfactory. But using this assigned value, but the normal curve that the regulation, for example, there is a directive for clean water that says that the sigma, the reproducibility should be at 10%, for example. Then it's all the results that are in 50 milligrams, 55, 45, should get good results because they are following the rules that the regulation is marking. So if using this in the set score, you can be rejected, but having afterwards a result that is within the population with the sigma target that has set from the very beginning. So there is one more. Hello, my question concerns the significant number of participants for PT. Is half of participants enough to calculate set score that is reliable? Okay. It is important. It's important to have a significant number of laboratories. In our case, there must be a number of laboratories participating in the rounds that allows us to get at least 8 participants that have not been removed as outliers. So at least there must be more than 8. This can happen in new parameters and parameters where rarely are measured in many laboratories, because the common situation is that we have a lot of laboratories like 30, 40, 50, 80, 100, 300 in some rounds, for example. But it's very important. The most important thing is to have a minimum amount of laboratories that can give you a reliable assigned value. If we foresee that maybe we won't have a reliable assigned value, is when we, in our design of the round, we assigned this value with a reference material, with a spike sample checked by a reference laboratory, etc. So this is when we don't trust that the assigned value will be reliable enough. And so, and how is half of participants enough to calculate set score that is reliable? Well, half, I suppose that that means that is a half of the ones that have participated. Yeah, all depends on how many laboratories finally have are assigning the value, because the uncertainty of the assigned value, doing something very simple, is calculated like that, like the is that experimentally, the standard deviation that experimentally have gotten the laboratories that haven't been erased, that haven't been rejected, divide by the number of laboratories that has been accepted. So if this uncertainty that it has been calculated, if this uncertainty is lower than 0.3, the target that we set, then we can confirm that the assigned value is being reliable. Okay, so all depends on the case. It's not common that half of laboratories are removed, not at all. But finally, what is important is that this number of laboratories are enough to get a small uncertainty. This is why it's very important that the number of laboratories should be high in order to make this uncertainty lower. Okay? And I think that, well, it's 10. I think that we can, well, we have some other questions, but if you like, because we have, we already have stolen 1 hour of your life, of your professional life, which is just landed in after holidays. All the questions that you have given to us, we will answer by email, because we have your contact. We will send you the presentation, the complete presentation, as I told you, and our catalog. And if you want to come with me, we are very welcome when you want to enroll in one of our rounds. And I hope to see you in one of those next time. So yes, thank you very much for your time and your, we hope that you have enjoyed and your expectations has been covered. Yes. So
it's it's a lot of information to be put into an hour. So I hope it's clear, but if any doubts, you can always contact us and we will be more than happy to resolve. We have here our expert.
Only one
of our experts, lots of experts. So we have in GSC, but she's been, as she said at the beginning, 30 years in this business. So anything that you need, we are here for you. So many thanks for your time. I know it's an effort for some of you to be here with us. And
I hope to see you soon.
Yes.
Okay, thank you. Bye. Bye-bye.